this is going to be a bit of a montage of the making of our propulsion module. This is the pipe that we are going to use. This is the thing that we hook it together with. This is an end cap. And this is going to go inside the hooking together to make sure that the ping pong ball doesn't fall too far in between. This is a tape measure.
Cool beans.
So I have now a small piece that's going to stop our projectile from going all the way down into the place where we are going to use gas. And now all that's left is to stick it all together.
Good stuff, everybody. Cool beans. Let's get to it.
What we're calculating here is the impulse, and impulse is the amount of momentum imparted to an object from some force over some amount of time. And to find that, we are using a kinematic equation to find the acceleration of the ball. And then we're plugging that acceleration into Newton's second law, which is F equals ma. Then after that, we are plugging the force that we found into the impulse equation, which is J being impulse, equals force, which we just found, over time, which we found by counting frames in the video which we shot, and it is 0.6 seconds. And we plug that all in to find our final answer.
Our first example is a collision where a mass strikes a mass of the same mass.
What you just saw was an elastic collision. And my favorite example of an elastic collision is two billiard balls bouncing off of each other, and the first one imparting all of its momentum into the second. Now, our collision wasn't perfectly elastic, and because of that, we had to do some spicy equations. So basically, we calculated its inelastic momentum, and then we chose 90% arbitrarily because it seemed correct, and then we found 90% of the velocities, and then that gave us our final momentum.
Our second example is where a mass strikes a mass infinitely greater than it.
When an object strikes another object that is infinitely more massive than the first object, the first object will bounce back with the exact same momentum it had before striking the second object.
Our third example is where a mass strikes a mass about 8 times greater.
Fatality.
In this collision, our ball collided with a mass 8 times greater, so 24 grams. We laid out the variables and our equations, and then solved for V1 final, which was the ball's post-collision velocity, and for V2 final, the post-collision velocity of the bottle. Since this collision was completely elastic, we did not need to solve for and average the inelastic collision values.